Hi, Alg2. In this lesson, we're going to be working on geometric sequences. So not arithmetic, now we're looking at geometric. Here we go. In a geometric sequence, now we're looking for a common ratio, or sometimes we call it the common factor. And think about exponential functions, but with slightly different notation. In these examples, we want to determine whether the sequence could be geometric or arithmetic, so we'll be reviewing that as well. And then, if possible, find that common ratio for geometric or the common difference for arithmetic. In our first sequence, I'm noticing that each time here we are subtracting by 7. So that means it's not geometric, but it is arithmetic because it has that common difference. In the next sequence, I first noticed that I'm dividing by 2, but then that is not going to hold going forward. So I try something else. Maybe we're subtracting 90, but that is not going to hold going forward either. So this sequence is neither arithmetic or geometric. In this last sequence, I notice that we are dividing by 5, but in our geometric sequences, we're always going to be talking about what we're multiplying by. So dividing by 5 is the same as multiplying by 1/5. And I notice that that does hold. It is the same all the way. So this is geometric. And our common factor is 1/5. That means that that's what we are multiplying by. Here's the general rule to find any term of a geometric sequence. Again, this is an example of an explicit formula. And a sub 1 is going to be your first term. And then r is your common ratio, which we just saw in ours was 1/5. And then n is your term number. Compare that to an exponential function. Remember, a here was our initial value, or our first value, and then b was that growth factor, or our common ratio. And then x was, well, how many times are we going to be multiplying by that? So you can see some similarities here as far as first term, common ratio, and then our exponent. Here we're going to be finding the 7th term of our geometric sequence. I need to find our common ratio, which looks to be like we are multiplying by 4. So I'm going to start with our general formula, and I'm going to fill in what I know. I'm looking for a sub 7, and I know the first term here was 3. My common ratio was 4, and I'm going to put in 7 for n. And now I just have to evaluate that. After simplifying, I get my 7th term to be 12,228. Now we're going to find the 9th term of this sequence. So I first need to find my common ratio. And I'm noticing here that I'm multiplying by -1/2 each time. This one's weird in that we're alternating from a positive to a negative value with each term. That means we're going to be multiplying by something negative. And now I'm going to fill in my formula. I'm looking for a sub 9. My first term was 3/4. My common ratio was -1/2. And then I'll put in 9 for n in the exponent. And now I'm just going to simplify and evaluate to figure out what that 9th term is. And after working this one out and simplifying, you get the 9th term to be 3/1024. And it's a really icky decimal, so just leave it as a fraction. Now we're going to find the 9th term of this sequence, and I'm noticing here that with each term we are multiplying by 10. So that's going to be our common factor. So I go to fill in my general formula here, and I know I'm going to be finding the 9th term. So a sub 9 is going to equal my first term, which is 1/1000th, times my common ratio, which is 10 to the 9 minus 1 power. And after working this one through and simplifying, we get a sub 9 to be 100,000. In this one, we're going to find the 8th term of the sequence that has the 3rd term to be 36 and the 5th term to be 324. So we're not given a whole lot of information. Our general form, again, uses our first term, but we don't know that either. But we do know 2 terms. So I'm going to rewrite my general form like this. A sub 5, which I know, is going to be equal to a sub 3, which I know right here. And then here's what changes a little bit too. The exponent, n, is right here. That's going to be 5. And then instead of -1, you notice how 1 is the term number of this one? Well, here I use the 3rd term, so this is going to be 3. So I filled in what I knew here from the two terms that I was given. So now I can solve for r. I'm going to rewrite this and then work to get r by itself. Here I'm going to simplify that exponent to just be 2. I'm going to divide both sides by 36. And I end up here with r squared equaling 9, which means I'm going to take the square root of both sides. So I'm just going to get r to be 3, but it is going to be plus or minus 3. Now I have to try to figure out my first term, but I do have to take into account that r can be either positive or negative 3. So for my term that I'm going to be referring to through this, I'm going to use a sub 3 for a lot of my information. So 36, that's a sub n, is going to be the first term, again, which I do not know, but multiplied by my r, which I'm going to start with positive 3, and then to the power of 3, because 36 was the third term, minus 1. And I'll simplify this. When I simplified, I got my first term to be 4. But again, remember, that was just using the positive value of 3. I'm going to do this again using the negative value. I got my first term to be positive 4 again, which is good because that's going to save us some work in the long run. If these were different, then I would have to do this multiple times to figure out what my possible term is, given the starting value being different. Okay, to recap, we know our common ratio is positive or negative 3. We know our first term is 4. We are trying to find the 8th term. This is our general form again for a geometric sequence. And we have to do this twice. We have to do it if the ratio is 3 or if the ratio is negative 3. Here's my setup for the ratio being 3. Here's my setup for the ratio being negative 3. Now I just have to simplify both of them. I end up getting two different answers. It could be positive 8,748 or the negative of that. The last thing in this section is finding the sum of some terms of a geometric sequence. Here's our general formula to use. And here we go. We're going to just plug this in for this one. We want to find the sum of the first 8 terms of this sequence right here. We can see our common ratio is going to be 2 because it's doubling every time. And we see our first term there. So S sub 8, meaning the sum of the first 8 terms, is going to equal our first term, which is 1, times, in the numerator, 1 minus r, which is 2, to the nth power, that's going to be 8 in our case, over 1 minus 2. And now we just use our calculator to simplify that, and we would see that the sum of the first 8 terms is 255.